What's happening, guys? What's going on? Welcome. Thank you for joining the stream. We're doing some final setup here. Picking out our videos and all of that kind of stuff. Wanted to give people a few minutes to jump in here and just jump on and rap with you guys. The luxury of Google, the way that Google is executing this is they're all just videos. We can just kind of watch them at our leisure. But still, why not watch them together and get some commentary and have some conversations about it? Google Cloud's probably one of the fastest growing cloud providers right now in terms of, features that they're onboarding and things like that. AWS is certainly the stalwart. Azure is not far behind them. Frankly, I think they're better. Just my opinion. But Google Cloud has had my eye for the last couple of months as they continue to introduce a lot of things. So we're going to watch the keynote. It's about 25 minutes. I double-checked ahead of time. It's not very long. But this week is the big one for me. This is infrastructure for all of us that are old data center admins or systems admins that are trying to find our way in the cloud throughout digital transformation and things like that. This is the one that really rang true with me that I wanted to spend a lot of time on this week. So we may go a little bit longer today depending how the content is. And just to give you guys a heads up, we're going to be doing at least a couple hours here, watching some videos and things like that. But we may go a little bit longer if they're good and the conversation's good and there's a lot of interaction and stuff like that. So I'll keep this going. There's a ton of videos. Like you can scroll down here and see all the different breakouts. There's a ton of stuff that we can watch. This is my playlist that I've put together, and it's right at about 2 hours worth of content. So hang out, grab a drink. Let's just talk about what we're getting ready to watch. I will say this: 2020, we're wrapping up July. We're heading into August. We're heading into the back nine of 2020, and it with everything going on in the world right now, this scramble to do virtual events and things like that. I put a video on the channel back in May, I believe it was May 1st actually, on my thoughts on virtual events and what it would take to succeed. And I still haven't seen anybody really nail that yet. Everybody's still doing Zoom calls and Hangouts without a appreciation of quality that the presenters, both video and audio. We're still doing things over highly compressed. And they're just videos, so you should be recording these. Why they're being done over video conferencing mediums still astounds me. So that's one of the disappointing things from Google is that they're still, even though they're like pre-recorded videos, they're not pre-recorded videos. They're just recorded meetings. And I feel like there's a little bit of disappointment there that I wanted to see Google do a little bit more. Microsoft Build knocked it out of the park way back in April. And that was the big thing for me was, hey, Wences, yeah, do exclamation music. I think that'll give you actually, that's not the right one. I've got to make a new, that'll get you to the lo-fi beats, but I'll drop one in for you in just a minute. I've watched a lot of videos over the last 3 weeks from Google Cloud. And that's my one takeaway is that if you're opting to do this in a pre-recorded fashion, you didn't just have to record meetings. You could have funded a light amount of gear, at least a decent amount. Everybody's probably got a decent enough laptop to record with free software like OBS. So why not record in 1080p HD? Why does it have to be... Why do I have to feel like I'm in yet another conference and yet another meeting when I'm watching videos on your stuff? One of the beauties of going to breakout sessions at live events is it's the highest quality possible. The person's on stage 10 feet in front of me. So at least companies, and this is not meant to be a knock at Google specifically, but I feel like they were probably in one of the best positions to do this off the back of the success of Build and what the fails that we've seen, frankly, from other companies trying to do these. And you know what? Maybe my bar is just a little too high. Maybe my own personal expectations. But I feel like you're not asking much. You're just giving them a new camera and a decent microphone. It might cost you $500 per presenter. And if you're pre-recording them like this, you can even share them and pass them around. So I don't know, man. I'm a little bit discouraged. I wanted to see companies do more than this. I wanted to see more than just a pre-recorded Zoom meeting. And that's really the one thing that I've got a hang up on with this. But we're gonna watch them. I'm excited to see what they've got to say. I'm excited for the technology. As fast as Google Cloud is growing, some of the biggest companies out there, Twitter and what was it, Etsy, Fitbit, they're all using Google Cloud. So I've got a whole slew of things here in my playlist that we're going to go through. Equifax using GKE. We're going to watch something on that. Cloud migrations. Twitter's global network. We're going to look at what that looks like in a breakout session. And then we'll take a peek, and we're going to talk about, there's going to be some storage stuff in here. There's going to be compute stuff in here. This is the infrastructure week. This is where a lot of my focus, grilling, we're getting ready to start in just a second here. We're going to start with the keynote. But yeah, we'll get started. I'm anxious to see what they're going to be doing. Hey, Gina, thanks for joining. All right, so let's get this party fired up. And make sure I got this ready. All right, let's kill the music, and we will get started with our keynote.
Welcome, everyone. I'm excited to be back here to talk about how Google Cloud is helping enterprises complete their digital transformation journey. As the global response to COVID-19 evolves, businesses everywhere are adapting to the ever-changing environment that forces them to think differently. And our focus at Google Cloud is helping you navigate the impacts of COVID-19, whether that's helping your employees work remotely or ensuring services are available. And during this time, our customers have embraced the elasticity that Google Cloud provides by either reducing cloud spend in times of uncertainty or scaling up their usage to meet their digital growth. And the backbone of this elasticity is our network. It's the world's largest and low latency network present in 24 regions, 73 zones, and 144 edge locations. It enables companies like Target, PayPal, Discovery to both migrate existing enterprise workloads quickly to GCP and build new transformative applications. In addition, it protects Google Cloud against DOS attacks, larger than anything that has been reported to date in the industry. And we're continuing to invest in our global network and our global reach. This year, we have already launched 4 new cloud regions: Salt Lake City, Seoul, Las Vegas, and Jakarta. And we've announced 9 upcoming regions in places like Melbourne, Delhi, and Madrid. Now, in addition to providing the scale and elasticity for accessing your data and running your workloads, we allow you to easily turn them into data insights with our petabyte scale data warehouse, Google Cloud BigQuery, and to leverage state-of-the-art machine learning through our AI services. And here at Google Cloud, our goal is to make it easy for anyone to build and run software and deliver on a global scale reliably and securely. And today we want to talk to you about 3 areas that are vital to the success of running your business. First is our continued investment in Google Cloud Compute and Storage services for running your top-tier enterprise workloads and migrating them to the cloud. Second is our networking and security enhancements for your workloads. And third is how we are making it easy and efficient to manage them. Now I'd like to invite my colleague Jun Yang, GM of Compute, to share advances in Google Cloud Compute and Storage to help you run your mission-critical workloads.
Thank you, Brad. Our vision for cloud infrastructure is to provide planet-scale, distributed infrastructure that has security and reliability built into the platform. Many digital native organizations across every industry have turned to Google Cloud to help them with the digital journey in order to get a robust set of solutions to develop better software and deliver innovative experiences. Traditional enterprises across the industry are also trusting Google Cloud to run all of their workloads as part of the digital transformation journey. Today, I will share several updates targeted at migrating and running mission-critical applications on Google Cloud. At the core of our infrastructure is Google Compute Engine. With Compute Engine, you can run services at scale without worrying about infrastructure. No reliability worries, no scaling issues, and no one spending time on managing OS upgrades. And because one size doesn't fit all, we offer you a wide range of VM families to choose from. Recently, we introduced Efficient VM, or E2, in GA, our latest family of VMs. E2 are cost-optimized general-purpose VM featuring dynamic resource management that delivers the best total cost of ownership amongst all of our VM family offerings. E2 is our fastest-growing new VM family on Compute Engine and now offers new machine types up to 32 vCPUs. E2 is now available across all GCP regions. Our N2D VM family is also released, and it's based on AMD's chipset, providing excellent price performance. It is public available today. Moving on to storage, Google Cloud's persistent disk offers reliable, high-performance block storage. It delivers industry-leading price performance for both HDD and SSD to satisfy your needs. Today, we're excited to announce an expanded persistent disk product portfolio, giving you the ability to pick the performance that best suits your workloads. First, Balance PD. It's best suited for most enterprise applications, giving you the best price for general-purpose workloads. Second, Performance PD. It's suited for customers seeking the best price per IOPS for performance-sensitive workloads, such as databases or persistent cache. Third, Extreme PD, well suited for the highest performance workloads, such as SAP HANA or large in-memory databases. Our strategy is about tailoring your storage needs to your workloads so that we can deliver on your price and performance needs. Continuing with storage, we recently announced Filestore High Scale, a high-performance scale-out file system to support workloads such as electronic design automation, video processing, genomics, and financial modeling. With Filestore High Scale, which is based on Elastifile technology, users can deploy shared file system with hundreds and thousands of IOPS, tens of gigabits of throughput, and at a scale of hundreds of terabytes. Next, I'd like to talk to you about our efforts to help you to migrate your application to Google Cloud efficiently, so you can take advantage of the benefits of Google Cloud sooner. Everyone wants the migration to be as painless and as effortless as possible. We want our culture of innovation and partnership to help you easily migrate your on-prem application and infrastructure, and then modernize them as appropriate to drive digital transformation. This is particularly true for traditional enterprises with lots of legacy workloads. Enterprises like Carrefour or Home Depot have migrated their SAP, VMware, and Windows applications to Google Cloud to gain agility and reduce cost. To make things easier for you to rapidly migrate your application to Google Cloud, I'm excited to introduce our RAMP program. RAMP is a holistic migration program to provide a clear path to success in the cloud. It offers end-to-end migration guidance, tool sets, training, as well as incentive to help you offset a significant portion of the migration cost. RAMP also brings together a full suite of tools for every phase of migration to accelerate the migration process. It is publicly available today. For many customers,
We'll have to look into that.
Your on-prem infrastructure may be running on VMware. To make your VMware migration to Google Cloud easy, we recently announced Google Cloud VMware Engine, an integrated cloud offering that runs VMware's software-defined data center software on top of Google Cloud infrastructure. It allows you to seamlessly migrate your workloads running on VMware infrastructure from on-prem to Google Cloud without re-architecting your application or changing the way you manage or run your workloads. To learn more about this partnership, let's hear from Thomas Kurian, Google Cloud CEO, and Sanjay Poonen, VMware COO.
I wasn't expecting
Google
this.
Cloud partnered with VMware because we're in the business of helping simplify the cloud journey for customers.
Customers want to move to the cloud for scale, agility, lowering their cost, and developing a whole new set of cloud-native services and apps.
It eliminates the need for them to manage infrastructure and lets them focus on building new solutions for their customers.
Moreover, once your application have moved to VMware Engine, you have access to Google Cloud's innovation in infrastructure, analytics, machine learning, and AI, such as Anthos, BigQuery, and Cloud Operation, allowing you to derive more value from your application and existing data. To share their migration experience with Google Cloud, let's hear from Michael Gerg, Chief Cloud Officer from Deutsche Börse.
Deutsche Börse Group is one of the world's leading exchange organizations. We make trade easier, faster and safer by using Google Cloud as the foundations for a scalable, resilient and compliant infrastructure for financial markets. We needed the public cloud to improve agility, drive efficiency and gain access to cutting-edge analytics and AI tools. By using Google Cloud VMware Engine, we were able to spin up a new private cloud in under 40 minutes with minimal disruption, scale our business on demand, and meet our customers' needs while still using VMware tools and our existing processes. It gives us access to innovation while maintaining the same robustness, the same tooling as we have it today, with the benefits of added portability and agility. Google Cloud is so important for our business to unlock further potential for us as a company and for our clients. In the future, we will be able to innovate quicker than we have ever done before, and that's great.
Many enterprise customers also rely on SAP application and databases to run their businesses. Google Cloud offers an easy path to migrate your SAP application with a broad choice of compute options to run them efficiently and to benefit from Google Cloud's innovation in analytics and AI, therefore allowing you to derive more value out of your SAP operational data. We have many customers who are running SAP on Google Cloud. Let's hear from one of them, Careful.
Carrefour is focusing on providing our customers the best shopping experience, and the products must be high quality and also at the best price. We are preparing the future of Carrefour and implementing SAP on Google Cloud.
We need to innovate because the customer expectation changes dramatically.
We realized that we have a back office with multiple silos of information, so we need a lot of flows of information between one application to another.
In Carrefour Spain, we have more than 150 virtual machines. 40 virtual machines are for SAP HANA. The two main benefits on Google Cloud for Carrefour are flexibility and agility.
We can resize the environment at the same speed of the rollout of the project. We can switch it on and switch off. We can save money. We have this high ability, and also we have disaster recovery.
It is important to have a one data-centric model in order to provide one source of information for any other application. This is possible in Google Cloud.
We have added more SAP HANA and SAP NetWeaver certification to address the needs of large SAP deployments. First, for SAP HANA OLAP, we have achieved SAP certification for 6 terabytes scale-up. We're also announcing new SAP NetWeaver certification for our AMD-based N2D VM shapes, giving our customer additional CPU choices and better price performance.
Those are probably based
our
on the
SAP
epics.
Cloud Acceleration Program helps our partner migrate SAP customers to Google Cloud with migration assessments and incentives so that our customers can move their SAP application to Google Cloud without overlapping on-prem and cloud costs during the transition. We're adding new partners and serving more customers with this program every day. Lastly, we offer premium support that's most suitable for enterprise workloads. Premium support combines 15 minutes response time, proactive operational health reviews, case management integration with our customers' tools, and access to product experts to ensure our products are backed up with support that our enterprise customers expect. Next, moving on to Windows-based workloads. Google Cloud provides first-class experience for your existing Windows Server, SQL Server, and .NET workloads. We have thousands of customers already running Windows workloads on Google Cloud. It enables businesses like TELUS International, Volusion, and Travix to increase agility while reducing their cost. Google Cloud offers a myriad of services and capabilities for Windows application, including custom VM shapes, bring your own licenses, Windows containers on Anthos GKE, manage SQL servers, and manage Active Directory. All of these options can help you to run your Windows-based workloads easier and more cost-effectively. Many of you might be trying to figure out what to do with your Windows Server 2008 instances, either on-prem or in other clouds. Now that Windows Server 2008 has reached end of support, we want to make it really easy for you to resolve that. With Migrate to Compute Engine, as part of the migration process to Google Cloud, customers can now automatically upgrade your Windows Server 2008 instances to Windows Server 2012 in a single step. I have just given you a quick tour of what's new with Google Cloud Compute and Storage Services and what we're offering to help you to migrate your mission-critical workloads to Google Cloud. We're humbled to be able to help you in these unprecedented times and look forward to partner with you in your digital transformation journey. Next, I'd like to welcome Shailesh Shukla, GM of Networking, to share some exciting networking and security updates.
Thanks, June. So far, we have covered how we help you migrate important enterprise workloads to the cloud. Next, I'm going to talk to you about Google Cloud's networking services, as well as our approach to security. I'm also excited to talk about a major new partnership with Cisco. First, some key product announcements and updates. As part of continuing to enhance application performance and flexibility, I'm happy to report that Google Cloud CDN now supports serving content from on-prem data centers or even other clouds. For customers with hybrid or multi-cloud deployments, this provides more flexibility in content and application delivery anywhere. We are also enabling you to take an application-centric rather than an infrastructure-centric approach to connecting to services. We have two exciting new capabilities to help you make that vision real. First, Private Service Connect lets your businesses connect effortlessly to Google Cloud services or third-party SaaS applications like Salesforce and Snowflake while keeping network traffic private and secure on Google's network.
Okay.
Once you have connected to these services, Service Directory provides a single pane of glass to publish, discover, and connect services, simplifying the management of hybrid and multi-cloud services at scale. Moreover, we are pleased to see how quickly the industry is adapting a hybrid and open approach. Cisco is a key partner for Google Cloud, and previously we announced our plans to develop hybrid cloud networking together. We are now excited to announce an expanded partnership to bring the best of both Cisco and Google Cloud technologies together with a new turnkey networking solution. Cisco SD-WAN Cloud Hub with Google Cloud. Let's learn more about it.
Please.
The network is the foundation of hybrid and multi-cloud business transformation. You need a turnkey solution to securely bridge applications to networks across multiple clouds, modernize your enterprise, and reduce networking complexity with the best of Cisco and Google Cloud. Our joint solution will automatically provision a reliable global network that grows with your needs. Experience simple and flexible customer network access. Publish all of your services in one place and seamlessly extend intent to enterprise applications. Deliver context-aware and identity-based security management. Realize a fully software-defined end-to-end network. Get to know Cisco SD-WAN Cloud Hub with Google Cloud.
Okay.
I had a chance to connect with Muninder Sambi, VP Product Management at Cisco Enterprise, about this partnership. Let's hear what he had to say. Hi Muninder, welcome. I have a couple of questions for you. First, how does this joint solution help our customers succeed in their hybrid and multi-cloud transformation?
Nice question, Shailesh. Through this solution, these are two leading companies, Cisco and Google, that are joining forces to launch a solution that can help accelerate our customers' cloud-first journey. We are focused on three value propositions. It always starts in improving user experience through SD-WAN policy automation based on application metadata and telemetry data exchange between Cisco SD-WAN and Google Cloud. Our customers are also expecting lower operational expenses. They want to be able to improve availability and increase bandwidth. And we are able to do this by automating Cisco SD-WAN connectivity through the Google Cloud backbone to applications that are deployed in any cloud. We also want to be able to reduce risk and increase compliance with end-to-end policy-based access and enhanced segmentation.
Fabulous. Thank you, Muninder. So what makes the Cisco SD-WAN Cloud Hub with Google Cloud solution unique?
Now, Shailesh, you and me, we both are really excited about what we are launching here. I mean, this is industry's first fully automated solution that intelligently and securely bridges enterprise networks to any workload across any cloud. Our joint customers can now ensure that applications and networks are sharing service level agreement settings, security policies, and compliance data to provide a predictable application performance and consistent user experience. And we have to do this through automation. We are automating the Cisco SD-WAN connectivity to Google Cloud hosted applications from a wide variety of users or devices. And we all know how much IoT devices are growing in the enterprise. In order to provide a policy enforcement that ensures end-to-end compliance in any cloud.
That's fantastic. Thank you, Muninder, for joining us today. We are really excited to bring this joint solution to the market.
Thank you, Shailesh.
Security is Google's top priority, and our infrastructure is designed, built, and operated with end-to-end security as a core design principle. For customers in highly regulated environments, we provide required third-party audits and certifications, documentation, and legal commitments. Today, I'd like to talk to you about new Google Cloud capabilities for securing your compute resources, your network, and your connections to multi-cloud services. First, I'm excited to announce Hierarchical Firewall. This is a new product that simplifies how you manage firewall policies in large and complex environments.
So group policy.
It does that by allowing firewall policy control at the org and folder level, which provides consistent protection across the entire organization while safely delegating finer granularity control to project owners as needed. Second, last fall at Next UK, we announced Packet Mirroring, a service that allows you to collect and inspect network traffic across all machine types and regions with no overhead.
Wow.
Packet Mirroring integrates with third-party tools to help you proactively detect security threats and other potential issues. It is now generally available. To complement our encryption in transit and at rest, Google Cloud will now offer the ability to encrypt data in use, i.e., while it's being processed. This is called confidential computing, and the first product in our Google Cloud confidential computing portfolio, Confidential VMs, is now in beta. Confidential computing can unlock computing scenarios which previously have not been possible. Organizations will be able to collaborate, all the while preserving the confidentiality of their data. We are excited to offer this level of security and isolation while giving customers a simple, easy-to-use option that doesn't compromise on performance. Further, in the area of network and application security, workloads on GCP are protected against web application layer and planet-scale DDoS attacks automatically. With Cloud Armor, you can configure policies with geo-based access controls, pre-configured WAF application protection rules, and a custom rules language to create custom Layer 3, Layer 4, and Layer 7 filtering policies. Today, we are announcing the beta availability of Cloud Armor Managed Protection, which offers several service tiers, including an optional alternative subscription-based pricing model. With Cloud Armor Managed Protection, you get enterprise-grade DDoS protection on-prem or in the cloud with multiple service tiers. As you extend your workloads from on-prem to cloud to multi-cloud, it is imperative that networking availability, bandwidth, and security have to be in place to keep everything running. To that end, you need to have visibility into your network and quickly troubleshoot issues that span across these environments. In order to achieve this, we recently introduced Network Intelligence Center. It provides unmatched visibility into your network, along with proactive network verification and security recommendations. Centralized monitoring reduces troubleshooting, time and effort, increases network security, and improves the overall user experience. Today, we are announcing two new modules in this platform. First, Firewall Insights, which brings intelligence and proactive management to network security. Second, Performance Dashboard, that offers real-time network performance visibility into packet loss and latency at a per project level.
So it's a knock in the cloud.
As you can see, we are
Cool.
helping you migrate your workloads successfully and connect you to our secure and global network to take you farther than ever before. Now, I'll turn it back over to my colleague Brad Calder to conclude.
Thanks, Shailesh. The services June and Shailesh described are built on our core infrastructure that provides the highest levels of security, reliability, and scale. In addition, we want to make it easy for you to use Google Cloud efficiently so you can maximize value for your business. Towards this, we recently announced Active Assist, our new solution that uses ML, automation, and intelligence to make cloud administration easier and smarter. This helps you and your teams identify the cause of issues quickly, easily troubleshoot those issues, prevent mistakes from happening with intelligent analysis, and provide proactive recommendations to optimize your usage of Google Cloud. And Google Cloud is the first cloud provider to provide this level of intelligence in its infrastructure to help you manage and secure your applications.
That's true.
And another area we are providing assistance in is in patch management. This is to help protect your running VMs against defects and vulnerabilities. With patch compliance reporting, you'll see proactive insights on the patch status of your VM instances across Windows, Linux, and hybrid clouds. And with patch deployment, you can automate the operating system and software patch update process, reducing the time you spend on these tasks. This means you can now easily maintain compliance across operating system environments and automate guest OS patch deployments to keep them compliant. So in wrapping up, we are excited to have you leverage our new capabilities for your digital transformation journey. To summarize the main announcements from today, for migration, we have solutions to make sure you can seamlessly migrate your workloads to Google Cloud, and we're excited to introduce Google Cloud VMware Engine to provide faster and easier migration of VMware workloads. For enterprise applications, we have new VM families and new capabilities for SAP and Windows-based workloads. And for networking and security, we're introducing confidential VMs and enhancements to Cloud Armor to make sure your workloads are secured on Google Cloud. And finally, to make it easy and efficient for you to manage your application, we're introducing Active Assist, Network Intelligence Center, and Patch Management. Thank you for your time today, and I look forward to making you successful on your journey to our cloud. Thank you.
Well, we got some stuff to chat about, for sure. So the first thing that really popped out for me is this really the first announcement of VMware on GCP? I thought it was out for a while. It was, no, Eric, it was, I'd say about a month ago. I mean, it hasn't been that long. There was a whole thing that I couldn't really keep up with where Microsoft unloaded Cloud Simple. Google Cloud bought them, repurposed it into something else, and it's still kind of Cloud Simple under the covers, but it's the same concept applies. It's you're basically running a dedicated, VNet or VPC that's basically like a shell for your SDDC. It's got your vCenter and all your hosts and all that stuff in there. People that are that's gonna be a big thing when it comes to Anthos and things like that. But at the end of the day, it's really about, it's what I said a couple of years ago. I can remember having these conversations a couple of years ago where I said VMware is going to have a leg up if they ever get their together and figure out that their biggest customer base is their existing enterprise customers running vSphere, the entire platform, and really refocus on vSphere as the core of everything and stop trying to spend all this time on all these auxiliary products. And it's coming to fruition because it's not, as we saw with the physical to virtual migrations of the late 2000s and early 2010s, it's not as turnkey as everybody thinks it's going to be. So this is more of like I call it, this will be the virtual to cloud. We had P2Vs. And what was the first thing we did after we did a P2V? We started creating a brand new VM that was lighter, didn't have all of the bloatware that the servers came with, all of that kind of stuff, right? So the minute we got the P2V done and we got the server out, the physical box out of the rack, we created a brand new VM and rebuilt it from scratch, migrated the data that was much more lightweight, much more performant, much more ideally sized. Didn't have too many vCPUs, didn't have too much more memory than it needed, all that kind of stuff. I think what's going to happen here is you're going to see a lot of V2C. So by that I mean virtual to cloud. You're going to do this V2C operation. You're going to move things into existing VMs into this cloud shell, and then you're going to immediately start standing up instances that are scalable, maybe that are containerized workloads for applications themselves, rather than having a whole VM structure. And then you'll just have a pool of instances that the application can pull resources from. So we're going to be doing this for about the next 3 to 5 years. Like, this is going to take us through most of the decade, much like it did with virtualization. This all started happening 2018, right? I remember I saw my first vMotion in 2006, but it didn't really get mainstream for VMware until 2010, 2011, really. A good 5-year window in there. Right? So if we relate that, we kind of just saw our first vMotion a year or two ago. We got 3 to 5 more years of this kind of stuff. Is really what I'm getting at. Let's see. Is this something to compete with Velo Cloud or NS? Yeah, I think the SD-WAN thing, it was a big, long, funky title that had Cisco in there somewhere. I think what this is sort of a meta layer of networking that lays on top of all of your cloud providers and those resources and instances that are in there, and then it also layers over top of your on-prem facilities and allows you to interconnect all of it. It's smart. It's really where Cisco needs to fit into this equation. Connect all the things. I don't need you to be my storage, Cisco. I've got plenty of options for that already. I need you to master one thing, and that's making sure that all my things can talk to each other. Let's see what else. What else are you guys talking about in here? You really need to dig into Anthos. That networking claim seems like... Yeah, he was saying applications in any cloud. To go back to what I was just talking about a second ago with that the other thing, Cisco layering over the top of it. All right, so we got some options here to choose from. We've got a sort of a customer scenario, harnessing migration, how to migrate to GCP and Kubernetes. Let's stick with the traditional workloads, though. Yeah, this is the one I think we want to watch next. Managing your VM fleet. So this is the one I wanted to jump into next, of how do we do things if it's going to be Google Cloud VMware Engine or if it's going to be just instances, just VMs, Windows and Linux. How do we manage all of that stuff? And does any include private on-prem? Yeah. I think Anthos is going to really tie all of this together in a big old bow, much like vCenter did. I think we're going to see... Anthos was originally pitched as a hybrid cloud application platform, but really what it's going to turn out being is a meta VMware management and a migration tool to end up migrating traditional virtual machines to cloud instances. I think. Gut hunch. So let's see what this one's all about. Managing large fleets of compute VMs.
Big hello and welcome everyone to the session CMP 103. This session is about how do you manage large fleets of Google Cloud Compute Engine VMs. And I'm Ravi Chintalapudi, a product manager in Google Cloud. And today I'll walk you through a few solutions what we are building to address a lot of our customer challenges, what we have heard from you all when managing large fleets of Compute Engine VMs. So I'll start with the very high level. What are the different problems, what we have heard from you all, an aggregated way, summarized way there. And then we'll talk about what are the solutions we are building to go address those challenges. In that specifically, I'll drill down on patch management, configuration management. I'll also give you a background on why we chose this and how we're going to go progress and make our roadmap. Going with demos, deep dive in demos, and wrapping up with roadmap. I understand you'll be listening to a lot of sessions in Google Nest.
Thank you, Eric.
Next. So there'll be a lot of data. It's very hard to remember everything.
I'm a terrible streamer.
There's one key takeaway, but there's one thing I want you to remember from this session. That is this. GCP now provides automated patch management service, configuration management service across Windows and Linux, across your Linux distros, across your hybrid environments. Obviously, we prioritize GCP first, with things to come up in the near future. With that, I'll get started. So as I said, I'll start with what are the top challenges, what we have heard from you all when managing your large VM fleet. Then we'll talk about how are we addressing that. In the interest of time, I'll talk about only a few of them. The first one, if I start with, as more and more customers starts migrating their applications, building their applications in GCP, they're often dealing with thousands of applications, 10,000s of VMs, petabytes of storage. So managing this large infrastructure at scale easily and effectively has become a big burden for our customers. Second thing is, most of our customers are used to some management tools when managing their on-prem tools, on-prem infrastructure. So as they make their journey to the cloud, they expect the cloud providers like GCP to provide some native management tools, because either those existing tools are not compatible with the one which is running in the cloud, or they might be working with only specific cloud. Third big problem what we have seen is mostly from a security standpoint. Think of a scenarios where we had WannaCry, Meltdown, Spectre, where any of these vulnerabilities hit. The biggest thing on an IT admin's mind is my environment compliant? How bad is that? How can I bring it back to the compliant state? Are all my VMs in a desired configuration? Which of them drifted? Why
There's
drifted?
the first kid
How it
scream.
drifted? So a lot. So managing security at a scale is another big problem. Well, these are just some of the problems. Talking about what we have heard from a lot of our customers there. In the interest of time, I picked up the top thing what we heard. So what did really do after hearing to all these problems? So we building a suite of VM management tools. In that, we prioritize patch and config, keeping security and compliance as the top top priority for us. So for the next 15-20 minutes, I'll walk you through each of the solutions and how we build it, and how can you use it, how can you observe it, and with the demos. I'll start with patch management. Patching servers is not something new. Many of our customers, as you all know, we've been patching servers for years and years. But still, it is one of the top IT management problems. So we're really curious to know why it was such a big pain. So we started talking to about 100 plus customers across the globe, across the industries. Average size was really ranging from 500 to 20,000, showing that we've covered SMBs and even the enterprise thing there. And here's a quick summary. First thing is, a patch Tuesday comes, which happens on a second Tuesday of every month. The biggest thing on IT admin's mind, especially the patch admin mind, is what's the state of my compliance? How compliant I am, how bad I am. And this thing, I want this report across my environment, across my fleet. Whether I'm running Windows or Linux or different Linux distros, I want one report unified across my environment so that I can see the state. Second big thing what we have heard is reliability of patches. What does this really mean? As I was talking to many of the customers, one thing is super clear. Most of them are patching in a phased rollout. So they always start with their dev environment first. If that goes fine, they go to staging, then pre-prod to prod. They do this because they're worried that a particular patch or a package might create some incompatibility issues, might break their existing applications. So they're trying to hope to find any of the issues throughout this phased rollout, so that they'll find something and they can fix it before applying to the next environment.
Yeah, thanks, Microsoft.
Third big category, what we have seen in general, orchestrated patching. What does this really mean? Most of our admins said they spend nights and weekends only when they're doing patching applications, primarily when patching applications. The reason for that is they have to do a bunch of things before, they have to do a bunch of things later. For example, before patching, they have to make sure everything is working fine. The health checks are there, the agents are running, users are hydrated, load balancers are taken care, there's enough space. Right after patching is done, they want to make sure their applications are running. They will do the health checks, services check, and that's why they make sure that they always do it in the maintenance windows, like in the Friday night, Saturday night, and they spend a lot of time to making sure everything's up and running. And there is sequencing. They want to go automate these processes. When something goes fine, automatically roll out to next environment. When the dev environment goes fine, go to stage. So automatically roll out. Something go wrong, stop. Other big thing is application aware patching. So as I said, application is a key thing for any company. And when they're patching an application, they really want to understand the application architecture. So think of you're patching an N-tier application. You always want to go do a backend first. Your database is first, then backend. So you do a right order and everything. So understanding the application infrastructure, having a knowledge of that is super important. Last thing is, as I talked earlier, patching is not something new. Our customers have been patching for years. So there are a lot of existing tools. So anything we build has to make sure that at least integrates or provides a value on top of an existing patch management tools. Okay. So after listening to all these problems and reprioritizing, we thought like, hey, we came up with a solution. And where our vision is like, we want to go help our customers patch any OS anywhere. Any OS could be Windows or Linux. They could be running in GCP, non-GCP, but our priority is right now running in GCP. We launched GA in April this year. So that's the general available. You all can go use it. But the scope is at GCP, both we do Windows and Linux. What's a big value prop? As a customer, why should I use this? So that just two main value props you should think about this. One is like, I get a compliance reporting across my environments, across Windows and Linux in GCP, telling you what's bad, how bad it is that. Second thing is automated patch deployment, ability to go fix that problematic machines and bring it back to the compliance. And I'm going to go detail into each of this stuff there. So let's start double clicking on what is patch compliance. So as I said, when Patch Tuesday comes or any new packages get released from repo managers, one of the key things for patch admin is give me a compliance report across Windows and Linux. So with our thing, you get a dashboard. As you can see on the screen, you can get a view of which part of my environment is green, which part of my environment is red, which environment is bad, along with additional data. Because when I just show you a patch, compliance is not enough. I want to know what's causing me to read that red, what type of patches I'm missing, how many patches I'm missing, how long I've been missing. So because there's an action item for each of this. If I'm running a company and if I see everything red, that's a showstopper to me. I'm going to stop and go fix that. If everything is, most of them is green, but some are yellow, probably time for me to take a weekend off and come back and fix it around the next business day. So that's one big aspect, getting the compliance view your environment with the detailed metadata. Second big thing I want to call out is we tried our best to leverage native tools, native configuration, rather than reintroducing a lot of new tools. Yes, we do have our own agent, which actually does the job, but we actually go talk to the native Windows agent called Windows Update Agent or Moo. When we are patching for Linux, we talk to the native repositories like yum, apt-get, the repo managers and everything. And we leverage whatever configuration you have, whether you're talking to Microsoft Update, whether you're talking to WSUS, whether you're talking to repositories. The key thing is we're leveraging most of the native tools and config where we can.
Okay.
The last thing is on the supported operating systems. For Windows, we support 2012 and above. And Linux, we do Red Hat and CentOS 6, 7, 8 versions, Ubuntu 16, 18, and Debian. In our documentation, there's a clear supported operating systems link that will be constantly updated when we add new operating systems. So that's the first part. As an admin, I get the state of my environment, getting which one is good, which one is bad. But the next important thing for them is, how do I bring it back to the green state? That's my desired state. How do I bring it back, everything to green? How do I automate this process so that I don't have to worry about everything? And that's where the patch deployment comes after you knowing the compliance state. When you're patching machines or your environment, the four important questions come to any patch admin. First thing is, what VMs should I patch? Should I patch at my application level? Should I patch at my project level, GCP project, or a zone level, or a particular region level? So we provide you all the flexible targeting options. You could choose to patch all web servers because that's how you labeled it. Or you could to patch all my dev environment. So you have all the flexible filters. You can choose the way you want, which I'll be demoing in a few minutes when I go there. Second big important question as an admin they'll ask is, what type of patches install? So first one is what VMs, that's great. Second, what type of patches I want to install? Should I install critical, security, or others? Because I said every company have different SLAs. That's what we've heard. Windows is 30 days, say, for example, Linux could be 60 days, 90 days. So every company differs, but on average, every company have different SLAs to go patch. So it depends on the type of patches you want to go select. You want to select here, you need to have an option to select type of patches. That's the patch configuration I'm talking about. Couple of key things to hit here. Patch exclusion. And many times when you have a particular patch, it might break some of your line of business applications, or there could be some incompatibility issues. So you might want to exclude certain patches because you know that's going to break something. So there's a patch exclusion capability where you can specify a KB article or a wildcard in Linux like star.kernel if you don't want to install kernel patches. So there's a patch exclusion. Similarly, there is patch inclusion. Think of a scenario where you got a security patch and you want that to roll out to your environment immediately. Then you just put that patch, include only this patch, and roll out to all my environment. So that's a patch inclusion capabilities. So the first question was what VMs to patch. Second thing was what patches to apply. Third big question comes to customers is like, when should I patch? Patching is not a one-time thing. I'll be doing recurring. I could be doing like first day of the month, last day of the month, last Friday of the month. So we provide all those flexible options. You can do now, you can do one time, you can do a recurring, and you can choose different dates, times, weeks of the days, and everything. I'll go a lot more details when I demo that. The last part of scheduling is the maintenance window enforcement. Almost 90% of our customers told me that they'll patch only during a maintenance window. As we see people do it typically in the Friday nights, Saturday nights, or on the weekends. So they have a maintenance window set and they want to doing the patch deployment only during that time. So in our product, you can specify a window saying that, hey, start at 9 o'clock in the night on a Friday, but run for only for 3 hours. So we'll ensure that we run only that 3 hours, including the reboot, and we finish up whatever we're running and we get out of the process so that your app's up and running and coming. So after the 3 questions, what VMs, what patches, when should I patch? Last important thing is controls. What additional controls I would need? I talked about a lot of patch orchestration. That's one of the top concerns what we have heard from our customers. One of the big thing is ability to run pre-steps, something before patch. It could be health checks or disk space, and something to run after the patch. So in our UI, you will be able to select certain pre-scripts. This could be a script which we upload to a Google Cloud Storage GCS bucket, and we'll pull it from there and we'll run it. And you can also condition it. If the script fails, the patch deployment will stop. So you don't need to worry about like, hey, am I mass disrupting something there? The last part of the control was one of the major feedback what we have heard from beta when we released early this year was reboot control. Especially when you're patching applications, even though we do a controlled reboot, as a patch admin, I want to control my reboot because it's my application running. So we don't reboot if the user chooses this selection. It's a configuration option. We will not reboot. We will hand over the control to the user. So after the patching is done, they can come and control the reboot as per the needs. So that's about the 2 value props I've talked about. One is this patch compliance state, giving you the state of environment, how it is right now, snapshot. And the second thing is the ability to go fix that and automate this so future you don't have to do it. Those are the 2 big value props of patch management. Enough of me talking. I really want to show you how the product looks.
Yes, please.
In the UI. So in this patch management demo, I'm going to walk you through 3 things. The first thing is how do you onboard and navigate and onboard the patch management service. Second thing is how do you get the patch compliance. And third thing is how do you go do a patch deployment, basically go fixing those problematic machines and bringing it back to this compliance, and you can automate those processes. Okay, how do I navigate? So if I go to my Google console, go here, go to compute engine, and on the bottom you can see OS patch management. And this is the screen what you will see because you have not enabled the services. So and you can see what APIs we need, what permissions we need, and if you click on learn more, it talks about whole details about what is this service, how are you going to enable, how it works, what's the architecture, what does this agent do, what permissions, all the details. Once you enable the service and activate the agent, so the OS config agent is part of the most of the GCE base images, base image packages, except I think Ubuntu and SUSE, which we are working to add right now. So for those things, you have to do it separately. And we have a clear instructions how do you go install an agent. Especially after if you are using an older VMs, you have to follow that instructions how to go get this OS config agent onto the VMs. So now I enable the services. In the interest of time, I've already enabled it. I'll go to a project where I've already enabled the service. So once you enable and activate, we will go scan all your VMs, collect the data from all the sources, aggregate it, and generate this reports. Let me walk you through each of this stuff. The first style talks about all the VMs I have by operating systems. Looks like I've got 18 in this environment divided by different operating systems. Looks like my Ubuntu is good. It's not missing any red, so I don't have a showstopper. I can move on. Looks like CentOS is bad. I've got all the different categories I'm missing. I'm missing critical, important, other, and few are up to date. Similarly with Windows, and Red Hat is also bad. And if you want to know more about what are these type categories, what does each one mean, if you click on this particular link, it will take your documentation. Let me just navigate there. So if you go to a documentation page which talks about the whole charts, what you see there, and explaining what each one means and how do we compute that. Going back to the dashboard. Now if I'm an admin, I'm looking at this, I really want to know why is this bad. Let me know which VMs are having problems and what sort of things we already have this here. Okay, so you can also click on the VM instances page as well here. So you see the same thing, and here's where you'll see the different VMs, what you have. Part of that is, let me pick up the CentOS VM, which is having, and you can see all the metadata here, like what zone it is, what OS distribution it's running, what OS version, and it's saying that it's missing critical updates. When you go click on that, that's where it shows that, oh, I'm missing a lot of updates in this. 3 of them are critical, but other things are security and other important, something for me to take an action. So in the upcoming releases, we are adding a lot of metadata to show you a lot more data, like CVE score, what repo manager can connect to, where do I get this patch. It's a lot more information. In Windows, we are adding the KB links, the MSRC severity. So you'll get a lot more metadata in our upcoming releases.
This is really
cool. So
cool.
that completes the first part, where we have seen actually 2 parts. First, we have shown about onboarding. We have seen how to get the patch compliance in an environment, state of your environment. The third thing is, as an admin, I want to go fix this problematic machines. I want to go create a deployment so that installs the patches and brings these VMs back to the compliant state. So now I'm going to click on patch deployment. So as I talked earlier in the slide, there are 4 questions which really matters for patch admins when you're doing a deployment. First is, what VMs to patch? And we give you a lot of flexibility to choose different filtering mechanisms, whether you can patch by a project, a zone, I'm talking about a GCP project, zone, region, or you can use labels, tags, name prefixes. In this case, I'm using same labels called, hey, environment dev, all my dev machines I want to go patch, or I can choose to patch all VMs. Okay. So we finished the first question of what VMs to patch. Second important question is, what patches I want to install? Because every customer will have different SLAs for different patches. I've seen most of the customers have a critical and security have to be done within 30 days. If it is non-critical, they have a little bit more time, 45 days there. So we give you all the flexibility so you can choose what sort of patches you want. Like for example, critical security, that's the only thing I care about. Patch exclusion. So this is one I was talking about earlier. If you know that a particular patch or KB in this thing is going to break your line of business application or some incompatibility with a known thing, you can put that KB article. You can put multiple KB articles, comma separated. We will exclude that when you are installing the remaining patches there. And in Linux, you can do like kernel updates, or you can do wildcards. You can use any of those stuff there. The other hand, what you call patch inclusion, is you just want to install selective updates. Microsoft released a security patch, or they've got a separate package from Linux vendor. I want to install that particular security package on my fleet right now, or like as soon as possible. So you can include that particular KB article or the Linux, whatever the wildcards you are using to do that. Similarly, we do that same thing for both Windows and Linux. If it's running EM, Red Hat CentOS, or apt Zyper, you can choose your own configuration and do that. So that finishes the second question, what we had: number of VMs, what type of VMs, what patches. Third question comes to patch admins, like when should I patch? Patching is not something I do once, it's a recurring thing. So I need to give me all the flexibilities to do it now, do it later. So for example, if I choose end of the month, 12 a.m., or I want to be in a particular recurring schedule, like I want to do it on a specific day. I want to do it on a fourth Friday of the month, or I can do second Saturday of the month, second Tuesday of the month, aligning with Patch Tuesday. So whatever needs you have, we provided flexible recurring scheduling options, so you can choose whatever is right for you. In my case, I'm going to choose schedule for later, doing end of the month. The other key thing to talk about is duration. Almost every customer confirmed that they're going to install the patches only during the maintenance window. Typically happens on a Friday night or on a weekend there. So they want to make sure that the app is down at that time, no user is connected to that. So here you can specify a maintenance window, like a duration, how long you want to install the patches. If you want to install the patches, say for like 120 minutes, that's the only time we will be installing the patches. Including the reboot, we'll take care of that. However, we'll finish whatever the step is there. We'll not start any new step there. So the last thing which every patch admin will care about is rebooting. By default, the system will decide if the reboot is necessary based on the metadata, what I'm getting from the package or packages. But some admins, like I want to control my reboot. I'm patching my application. I want to make sure that this is actually working. I want to be in front of it, and I want to run some pre-steps and post-steps. So we give that options to choose never, so you can control it. For now, I'll leave it as a default system. The next comes the pre and post scripts. This is one I was talking about. A lot of admins want to run some things before to make sure everything is working fine. They want to run a lot of things after, make sure everything is working fine there.
Unmount all your drives.
Okay. How do you do
remount
that?
them
So you
after.
create your script, upload to your GCS bucket, Google Cloud Storage bucket.
Unmount
In our
databases,
documentation, we explain
remount
how do you
after.
get that script into the bucket. Now I can go click on that. It opens up a GCS bucket, and I can go select, hey, I want to go do this, my Linux prescript. And similarly, you want to do some PostScript. You want to go select this, and you want to go build this. Done. Then you create your deployment. So let me show you what happens if you create a deployment. For the interest of time, I've already created a few things. That's where you go to schedule deployments. So once you create a deployment, you can actually see it here. Right now, we have an option only to delete and recreate it if you want to make any changes. But in the near future, we'll be adding a capabilities where you can edit. You want to add more machines. You want to add in the configuration. You want to change the date. You'll be able to do all the changes. Okay, now I created it. When the time triggers, the patch deployment runs and it'll give you a detailed patch status. So let me show you one example there. So I've run some patch jobs last week, earlier this week, and it actually shows all completed. But there are some errors. So let me pick up a deployment which had a lot of VMs and it failed. So let me take this one which has got 16 VMs and it failed. First, it talks about a number of instances it has, Uber level status. If something errors occurred as an admin, hey, please take an action here. Look into that. How long was the duration when it would run? It will give you all the details. If anything was left in between or it's 100% done, and what classifications you have selected, gives all the details. Now this is the result state. If you look at in this state, some are successful in that 16. Some failed because there's no agent detected. Some of those configuration was not running or something happened. Some are inactive, which means that either machine could be offline or something happened, it's not running. So there could be other state there. Or the actual failed because of incorrect function for the patch. But here's a clear logs. If you click on any of the logs, you can clearly see all the details about this failure, why it failed, what time it failed. Typical verbose logs, you get that stuff. And this is where you can go to our Stackdriver logs to get a lot more details. Okay, so that completes the 3 parts I was talking about from patch. How do you navigate an onboard patch management? How do you get the compliant state of your environment? And finally, how do you deploy patches? To install those patches so that you bring that machines back into the compliance and set an automated recurring deployment. So every time it takes care of that. Now let's talk about the next service. It's on the configuration management. This is another service what we prioritize based on our customers' need and also keeping compliance in mind. So let me start with what are the top problems what we have heard with our customers when we spoke to them. The first thing is when you go create your VM environment, you want that to be in a certain desired state. Like I want security agents, I want monitoring agents to collect all the logs, or I want open certain firewalls, certain ports, certain accounts, or you want to have certain software. So that's first part. You define your desired configuration. The second big thing is how do I deploy this to entire environment at scale? How do I deploy this at scale? Third big thing is maintaining it. It's not about deploying it one time, that's all good, but how do I ensure that this is maintaining? I don't want any drifts. Whenever
Vic,
there
what's
is
going
a
on, man?
drift, as a user, I want to be notified. And obviously, I want to auto fix it later stage once I get a confidence. But at the minimum, I want to be notified if there is a drift. What drifted? Who caused drift? What happened? Why it was drift? How long it's been drifted? So you need to know all those details, what we call a compliance reporting from a configuration standpoint. The other big thing they ask is like kind of unified way, whether I'm bootstrapping or installing a Google first-party software or a third-party software, I need a unified way. The other big thing what we have heard from our customers, how do we integrate with existing CI/CD tools? For example, most of our customers use different third-party like CI/CD tools, like whether it's Jenkins, Packard, Spinnaker, any of the day their own tools there. They use our tools to go create the packages. And the key things, they want to take that package and deploy into their environment at scale and maintain it. So these are some of the problems. To solve some of the problems, we started creating configuration management, where our value prop is going to be 3 things: define, deploy, and maintain. So what does it mean? We'll help you to define your configuration file. Second step is we'll help you to deploy at scale your entire environment. The same sort of filters what I talked earlier in patch management, where you can do it at a project level, at a region level, at a zone level, or a different instance level, what I talked about. Basically giving a lot of flexible options so that you can choose how you want to deploy that. I'm going to give you a nice compliance dashboard across Windows and Linux, same way what we have done with the patch. So, and with a lot of additional data, as a user, you know which machines are in the compliance, which machines went out of the compliance, what caused it go out of the compliance, when it actually drifted. So you get a lot more details on that.
I wonder if it's based on
Let me walk you
Terraform.
through how the product works. From a user standpoint, when you have to go start configuration management, there are two things you should think about. One is I'm creating my desired config. This is, think of that as simple YAML file where you define your desired config. Hey, install a particular monitoring agent, install security agent, open this firewall. So you define all that stuff. We call that as a guest policy in our terms because you're applying a policy to the guest VM. Second big step is take that policy and apply what we call assignment to the bunch of VMs. So let me double click on each of the stuff. Guest policy, when I'm defining my policy or the configuration, you might want to say what packages you want to install, all this part of the guest policy. For example, in this example, I took an example of I want to install a Stack driver and I want that to be always installed. My desired state is always to be installed, as you can see in the screen. So in the same guest policy, now you define where do I get this package binaries from. So I want to install Stack driver, that's great, but go pull it up from this, the URL what I've given here, packages.cloud.com. And third part of policy would be if a particular software needs any configuration. For example, in this case, this is an MSI. I want to do it in a certain way. And if you have other configuration, like I want to do like silent install. So whatever configuration you have, you can put it there. So think of like guest policy, open up a notepad or open up any of the editors, create YAML file, put what package you want to install, where you want to get the binaries from, put any configuration. And the next step is, boom, take that and apply to a bunch of VMs. Now, let me walk you through how that happens in Pantheon console, which is Google Cloud Console. So in this configuration management demo, just like patch management, I'll talk about three things. One is how do you onboard out of the configuration management? How do you use the service? Next is how do you get this, creating a policy, applying the policy. I'll show you some of the G Cloud commands, then assignment. Okay, the first thing is onboarding. So if you have onboarded the patch management service, what I've showed earlier, that will enable all our the OS config APIs. So you're all taken care and you'll have everything done. You'll also have the G Cloud commands. You can start using it. When we launched the config management beta in the first half of the year, it's API only. So we are building the UI, the user experience there. So the API is already enabled. But in a scenario where if you want to use only config management, so I would go to same Compute Engine, or you can go to API services and just type OS config API, and you'll see a screen just like this where will be an enable button. In this case, I've already enabled, so showing disable button there. So once you enable it, it's the same API which powers both patch management, configuration management, and other services all we are building. So think of this as a common API layer where you can access that. Okay, that's the first part of creating the configuration part. Second step, as I talked about in my slide, the first thing is about how do I create my guest policy, which is my desired configuration there. So this start with any editor, whatever you have, and start drafting your YAML file. What package do you want to install? What configuration you want? Where do you get the repo manager there? Or you can take any of from our examples. So if you go to our configuration resource link, and I've added all of these things in the later parts of the slide, so you can actually look at that stuff. But if you go to Google Compute Engine and say configuration management, setting up config, you can see all those examples here. In this, we provide a lot of examples like how to install a Stack driver agent, how do you install other things there. So there's a lot of examples you can see. What state you want assignment, where you want to keep it. So a lot of examples. Then it talks about how do you create a guest policy. So this is a simple G Cloud command what we use to go create a policy so that it brings you into the system. So for my demo, in the interest of time, I've already created the policies and everything and got to the system. So first thing, I'll start with a simple view of show me all the policies I have in my environment. So let me increase the size a little bit so you can actually see better. So G Cloud, there's a beta because the OS configuration management is beta. Then we talk about OS config and guest policies list. Hit that. I think I've done two policies. I should see both the policies. One is a Stack driver policy, another Windows policy. Second thing is I want to know what exactly is in that Stack driver policy. So I want to say again, gcloud beta OS config guest policy. I want to say describe, and all the examples, gcloud examples and everything are in our documentation, so you can find out all the samples which gcloud to run when. Click on it, it would actually show the sample. In this case, I'm installing a Stackdriver agent. If we go up, it talks about where am I pulling the packages from. It'll talk about some labels here, as you can see. So which means that any VM just got a label called color is equal to red. That's where we'll apply this VM. So next time we create a new VM, put a label, this configuration will be automatically applied, and you can put some policy assignments there. Okay. In the interest of time, I took the policy and applied to a few VMs. So let me see how many VMs I got applied to. So you want to see like guest policies, you want to see describe, and you can also want to know what's been installed and everything there. So let me show that one as well very quickly. And the other command for this is gcloud command. And this actually saying same gcloud compute instance OS inventory list instances. So instances which has got this Stackdriver agent. So you can actually see that stuff, all instances what I have in that stuff there. So I've got 2 machines which have got this particular Stackdriver agent installed. Cool. So that completes configuration management demo, where we talked about how do you onboard the service, how do you create the compliance, your desired configuration, guest policy, how do you apply that on your this things, and how can you verify that stuff there. Cool. Let me go back to the slides. So the key thing is about roadmap. So as I said, we launched GA of patch management in April, the first half of the year, same time as we launched beta of configuration management. So the rest of the year, second half of 2020, we will be launching multiple versions of OS patch management, where we'll doing incremental updates, improvements. Some of things could be really simplifying that onboarding experience, applying a lot of customer feedback and getting a lot of feedback from our customers. Thank you so much for that. Really appreciate your feedback. And also adding a lot of compliance data, so making the whole experience very smooth. And then the documentation, when we launch it, will provide a clear details about what's coming in each of the launches. So we'll have way more details on what's coming in each of the stuff there. As far as configuration management, we launched the beta in the first half of it. And that's API only, as I talked earlier. Now we'll be building UI on top of it, the user experience, and a lot more other capabilities, which we are targeting configuration management preview by close to the end of the year.
Cool.
Okay, that brings to another important topic, pricing. This has been one of the topmost concerns, questions I have been asked from my customers there.
Free.
So let me reiterate a few key things here. This pricing, what we're talking about, is for both patch and configuration management, so both the services. There's no cost from now until end of the year, so you don't need to pay there anything until end of the year. Starting Jan 2021, we'll be charging per node, which is like per VM per month, of course prorated and hourly rate. Key thing is there's no cost for the first 100 VMs. After the additional one, say 101 VM, if the OS config agent is running and continuously sending the data and doing something, that's where you will be charged.
Holy smokes!
You will charge the rate of 3 cents per hour. So if you keep this, just for math, if you keep this running OS agent continuously 24/7, 30 days, you pay $2 per node per month for both config and VM. If you put a link here that gives you complete details in our documentation about what does OS config agent running mean, what sort of things I can do, I cannot do, how I get a charge. So a lot more details on that. Okay, moving on. So in this slide, I've included a lot of resources. So if you're getting started with how to do patch management, what's our architecture, how does this thing works, and I put a links for detail, how to create a patch job, how do you manage a patch job, along same thing with configuration management, policies, how do you manage these policies there, along with SDK links, API links. It's the same thing what I showed you earlier, just that we have a full link to the full page where you can see all the details about the supported operating systems, how to get started and everything, including some of our blog links. I would like to make one announcement. You must have already heard about Active Assist, which is a new solution to reduce the cloud complexity by providing some proactive and intelligent features. And it doesn't matter what you're running, compute, storage, security, billing, cost. So there are features in every area which helps you with some reducing, how to reduce the cloud complexities. In the below links, you'll have a lot more details than this. And I'm happy to say patch and configuration management are also part of Active Assist. Okay, moving on. Key takeaway. So I know I've covered a lot of content with like demos and everything, and hard to remember everything. But if there is one thing, the key takeaway what you take out of this session, this is this. GCP now provides an automated patch and configuration management tools across your fleet, across your Windows and Linux, across your Linux distros. With that, we'll wrap up. Thank you so much for everyone for your time today and going through this session. And especially thanks to all the customers who have given a lot of product feedback and make us help better the product the way it is right now. I continue to request that. Please go play with the product, give us more and more feedback to make it better. Thank you.
All right. I am going to go back. Gina, I hear you. I'm going to go back and grab... oh, God. Okay. Hang on. Where was it? Where's my playlist? Where'd it go? There it is. There it is. So what do we got? HTTPS g.co/cloud/active assist. That ought to get it. Pretty impressive, though. I want to go back and look at this one right here. So I distinctively remember running... We had WSUS 10 years ago. I don't know if it's still around as a thing or if it's even more integrated with System Center at this point. But getting WSUS up and running and trying to figure out why it broke, why the patches didn't run, and inspecting logs of each individual instance. Boy, it was a mess. And it was one of the banes of my... It's one of the first things I always delegated down to junior admins was managing patch updates. For config management, we mostly used... We didn't really have to get into config management too much. That was usually done at the application level. And we got away with doing config management using VM templates. So we made a series of VM templates that were blessed by auditors. And then we had to log and get signature on any major configuration changes, but we would roll those into a new VM template that any new VMs got created with that one going forward. So we kind of gamed the system a little bit is maybe the best way to say it, by getting around some of that. But I can see where it's one of the banes of trying to run hundreds, if not thousands, of instances in the cloud is dealing with patch management. Did the same thing, Vic? Yeah. No cost through the end of the year and a no cost for your first 100 VMs. Period, hard stop. And on your 101st, you pay $2 per VM per month. Let's see, if you had 1,000 VMs, that's... Well, I mean, that math doesn't even work, because you'd have to minus off the 100. So $1,800 a month. About 20 grand a year for 1,000 VMs. A year. I remember what our EAs used to cost. Part of the value of that was getting, unlimited WSUS licenses for endpoints. That's a big one. I haven't seen anybody else really nail that one yet. That's not to say that they haven't. It's just to say that I haven't seen it. And that's really what that comes down to. Week 3. Oh, this is my playlist. Okay. So I want to go a little... we've got migrations. We've got Windows workloads in Google Cloud. We've got GKE. which I don't know if I want to get into GKE right now or Kubernetes. I kind of want to watch a fun one. I'm curious about this Twitter global network one. I want to see, and this is a little bit more advanced stuff. So I really wanted to see what this one was about. And then we'll take a look from there. We'll see where we're at. Curious how long it is. Yeah, this is a good one. 23 minutes. All right, let's watch this one.
Welcome to Net 101, hybrid networking for millions of users with GCP and Twitter engineering. My name is Cynthia Thomas. I'm a networking specialist at Google Cloud. And I'm accompanied by Todd.
Hi, I'm Todd Siegel. I'm a software engineer at Twitter working on traffic and our edge infrastructure.
Today we're going to talk to you about how Twitter manages traffic to handle millions of tweets and leverages Google networking to augment their capacity. Let's get into it. Twitter is leveraging Google Cloud products that are built on Google's proven infrastructure. You're probably able to recognize some of these logos here. We supported over 1 billion users on 9 products, all relying on Google networking infrastructure. We've learned a lot and innovated a lot to be able to achieve such scale while ensuring reliability, speed, and security. That means better reliability and performance than the public internet and other cloud providers. Through this experience, we've been able to develop protocols that improve networking performance, like BBR and QUIC. BBR improves the previous TCP congestion algorithm, which was based on packet loss. Instead, Google has designed an algorithm to respond to actual congestion for available bandwidth and minimal round-trip times for huge performance gains. Another example of Google networking innovation is QUIC. It's based on UDP, a transport layer protocol that reduces latency by eliminating the number of handshakes compared to HTTPS over TCP. Twitter and Google Cloud users already benefit from these higher throughput, lower latency gains by accessing Google managed services like Bigtable and cloud storage. By the current numbers, we have 24 cloud regions across the globe, and several more coming down the pipe. As you can see, Google's made a large investment in infrastructure globally, including undersea cables, cloud regions, and partnerships with ISPs to deploy POPs and CDNs at the edge. We continue to grow our data center and cloud region count each year. This benefit means we can rely on Google engineering to deploy reliably and securely across the globe to benefit, for example, a Twitter user anywhere in the world for a better user experience. Here we can see Google's made a sizable investment in physical infrastructure globally. Google has built its own backbone, providing private connectivity between Google Cloud regions, data centers, and such. Just as Twitter has leveraged Google infrastructure for cloud services like Cloud Bigtable, edge networking, cloud storage, Google Cloud users can also benefit from Google's dedicated infrastructure for performance and security. As Todd will discuss, Twitter has complemented its own infrastructure by bursting and adding capacity using Google's global footprint. Twitter is already taking advantage of Google Edge networking, including our POPs for private dedicated interconnects, peering, and our Google front ends for caching, load balancing, and securing against DDoS at the edge. One major differentiator for Google Cloud Networking is the shared global VPC model. So Twitter takes advantage of this model where the shared VPC allows centralized management of Google Cloud Networking. So that means subnets and routes are reachable across the entire global VPC, which means great ease of management while never traversing the public internet. Additionally, this means you can deploy Google global constructs like the Google Global Load Balancers to deploy Anycast VIPs, minimizing the amount of configuration and providing a great end user experience. So there's a host of Google Cloud networking products and capabilities that Google Cloud provides, powered by our proven infrastructure. We have various ways to connect your on-prem to our cloud, secure your workloads with numerous security options, and scale applications through our load balancers and Cloud CDN. And furthermore, take advantage of orchestrated workloads through open source standard platforms like Kubernetes and Istio, the roots of which come from Google. So during this talk, we'll discuss some of the edge networking features that Twitter leverages from Google to scale. This includes the Google Global Load Balancer and Cloud CDN. Next, Todd will get into how Twitter deploys at the edge.
Yes, please.
Thanks, Cynthia. So I'm going to talk a little bit about Twitter's edge network before we expanded our network with Google and some of the issues that we were facing and how we solved them. So Twitter's global edge network is made of multiple points of presence deployed throughout the world. And we also have a global backbone network that this edge connects to. The edge then forwards traffic on to our serving regions that are located in a few different places throughout the world. When we originally deployed this network, we had different IP addresses in different locations, unicast IPs or regional IPs, and then we would have different DNS responses based on where the user was. We eventually changed this to be globally anycast VIPs, which greatly improved availability because of some of the issues with DNS caching or imprecise geolocation. So availability was good at this point. However, performance wasn't always good. So some of the challenges that we've run into are, first of all, Anycast is optimized by the carriers, by the individual service providers. They can set their own policies. Twitter can't necessarily control making sure that a certain service provider provides the best experience for Twitter users versus other users. The service provider may optimize for their own traffic or for different types of traffic versus Twitter traffic. Another issue is with capacity and with location, getting close to the users. If Twitter wants to add a new location on our network, we have to do a lot of research and we have to incur a lot of cost and engineering. So it's difficult if the World Cup is going to be in a new location where we don't have good connectivity or a good pop, a local pop, or the Olympics are going to be somewhere, again, where it's challenging for Twitter users to connect. It's difficult for us to quickly add a new location, especially if it's going to be somewhere temporary, where we just need a burst of capacity. Let's look a little bit into some of the problems with Anycast IPs that we've seen. So with our Anycast IPs, our end users, so here, let's assume that this purple icon is a user somewhere in Europe that's trying to connect with the Twitter edge. They have the Twitter global Anycast IP, and that edge can resolve to one of n different regions, one of n different edges that exist in Europe. It's up to kind of this blob called the internet to figure out if this will go to edge A or edge B and the path it takes to get there. And this blob is actually made up of lots of different hops, individual service providers, transit providers, and various agreements between them on how traffic is routed. And this can change throughout the course of a day and based on a variety of settings that are made by people frequently. So the path from the end user to Twitter is not always going to be the most optimal path. Additionally, when Twitter has to send the response back to the end user, Twitter can just choose the first hop back. Then that one may take a circuitous route back to the end user. Again, both of these directions may not be optimal at a given point in time. They could be based on time of day, network feedback, round robin algorithms, a variety of things. So this is pretty good for availability, but it's not great for latency. Furthermore, it doesn't always seem logical to our engineers, or at least to me. This chart shows where requests from users in South Korea, which Twitter edge the request ended up on in the course of a day, during the course of a day. I personally would have expected almost all of the requests to show up at our edge location, which is in Eastern Asia. We have multiple locations in Asia. I would have expected that the South Korean user requests would end up there. Turned out only about 60% of requests ended up there, where the other 40% of requests ended up going to Europe or going to the US. We also noticed a lot of deviation in the overall latency histograms, large standard deviation. Some of this is attributed to the return path that Twitter was taking, or just some of these really long paths that the user requests were taking. So improvements that we've made
This is fascinating, by the
to
way.
mitigate some of these problems. One of them has been to expand our edge by using the public cloud, specifically the Google Cloud, the Google load balancers. So this has really increased our global footprint. So however many POPs we had before, now we also have the entire Google POP network as well to ingress user traffic with all of Google's BGP optimizations and peering agreements with the various service providers and the return paths as well. Also, we've acknowledged that we can't control making sure that service providers provide the optimal path from a specific user to Twitter. So what we've decided to do is we've set up a variety of different VIPs instead of a single global Anycast VIP or a single set of global Anycast VIPs. And what we've done is we measure all of these different VIPs, and then we can optimize how an individual user connects to Twitter by finding the best VIP for that user. So looking back at this diagram again, the end user, we can give them our global Anycast VIP. They can connect through the internet through all of those hops and end up at Edge A or Edge B, and then we can return it to them. We can also provide another VIP. In this case, this VIP also took the same path to Edge A, but perhaps in this case, Twitter's BGP policy says that the return path will always go to a specific provider. And we can measure how this red and this black path are performing over the course of the day, and we can prefer one or the other for our individual end users. We can also set up Anycast VIPs so that our user is making a request and it forces them to land on Edge B in this case, or perhaps it doesn't work. We can again measure it, and we can provide this if it's a good option for the end user. Also, we can set up lots and lots of VIPs in the public cloud that route to Google edges, and then also provide Google various ways to route back to Twitter and measure all of these as well. The system we've set up that uses real-time measurements to choose from one of hundreds of different VIPs or routes back to Twitter for individual end users, we call it the traffic control tower. We steer individual users to the best VIP for them at that moment. And we use a variety of information. We use net blocks, subnets, ISP identifiers, and country codes to figure out how to group measurements together. We're able to route around problems that we see in the internet. We're able to find optimized routes from a user to Twitter and back. And it's proven very effective for us. I'm going to hand it back over to Cynthia to talk a bit about the Google network, and then we'll look at how Twitter specifically uses the Google Edge.
All right, thanks, Todd. So yeah, as Todd mentioned, the internet can definitely present itself with inconsistent behavior on the traffic path. So clearly the network matters and is really important to the end user experience. With Google's private backbone, we can provide two types of networking tiers. So there's the standard and premium tier. So the premium tier is a unique combination of providing speed and reliability, riding the Google private backbone. So the best analogy is pretty much like a hot potato, cold potato type behavior. So the default alternate behavior would be like hot potato, getting rid of the packets and handing it off to the internet as soon as possible. Whereas with the Google Premium tier, we basically hang on to the packet as long as possible, deliver it, ride it over our private backbone, and then deliver it as close to the destination or user as possible. So this enables basically a better reliability, performance, security, and a better user experience. So one networking construct that Google provides is the global load balancer with Anycast VIP. So this load balancer can be used for global reach for users to quickly enter the Google backbone and infrastructure and traverse the private network to its destination. It provides worldwide capacity, cross-region failover, and fast auto-scaling, and the ability to provide or handle millions of queries per second. So Twitter actually leverages the Google Cloud Load Balancer for edge reachability of services. And this basically this global load balancer can be combined with both Cloud CDN and Cloud Armor for both caching and security services while scaling. So one powerful behavior of the global load balancer is the cross-region failover, the overflow to other regions. So traffic is actually proxied to backends by a special algorithm called the waterfall by region. So if an entire region reaches capacity, the waterfall by region algorithm is triggered and traffic can overflow to the closest region.
I wonder if that's similar to the ring pairs that they use in Azure.
And traffic can also be preemptively overflown to other regions in the event of unhealthy backends in a certain region. I just want to talk a little bit about NEGs, so network endpoint groups. This was introduced, actually helps a lot in containerized environments, where without NEGs, there was an IP tables rule that would hop from one node to another. So there's this extra hop introduced. Network endpoint groups is basically a collection of endpoints defined as an IP port pair. This allows things like pods to be directly reachable as backends to the global load balancer. So what's interesting about that is you can use NEGs in other definitions as well, like internet NEGs, which would align to endpoints that are actually outside of Google Cloud. So next, Todd will get into the details of how Twitter uses Google Cloud load balancing in their deployments.
Thanks, Cynthia. So there's two primary ways that Twitter uses the Google Edge. So we use Google's POP network, which is all over the world, and we accept two types of requests through the load balancer. One is layer 4 only, and the other is layer 7. So in this first example, we're looking at how Twitter uses Google's TCP proxy. So in this case, the Google Edge closest to the user that will steer the user to based on our traffic control tower system will terminate TCP for the end user, establish a persistent connection with a Twitter service, which is running in GCP in the Google Compute region. And then we will then proxy that TCP connection back to one of many Twitter VIPs. In this diagram here, you see there's a blue, a purple, and an orange VIP that the Twitter service in GCP will hand off to. These represent different paths back to Twitter. So some of them ride on the Google backbone as far as possible. Some of them hand off as quickly as possible from Google to the Twitter backbone or private interconnect. So in this case, using layer 4 only provides some additional security for Twitter in cases where we want the certificate to always remain in the Twitter POP or in the Twitter infrastructure. Or else it provides us with some additional compatibility if we have some Twitter clients that have special Twitter only level 7 behavior, various protocol idiosyncrasies, etc. Additionally, we use Google pretty heavily as a layer 7 proxy, and we get multiple benefits in this case. So again, we set up multiple VIPs that all correspond to the worldwide Google Edge, and the different VIPs use the internet NEG that Cynthia was talking about before to route back to one of n different Twitter backend IPs. And these IPs, again, they correspond to different routes back to Twitter, either over the Google backbone or over the Twitter backbone. And again, we measure those and send the user to whichever one could be performing the best, or perhaps where we need additional capacity. And I'll talk about that shortly. In this case, as you can see, the Google Edge does everything. There's no service that Twitter has to run inside GCP. There's no deployments we have to do. There's no monitoring we have to do besides overall
You're
Google
just
load
routing
balancer
through their
monitoring.
POPs.
So this has been really great for us and reduced the amount of operations and deployments that we've had to do to GCP.
That's cool.
Let's take a look at what this has done for our end users. With a combination of the control tower and expanding our edge to regions and to locations in the public cloud, we've been able to pretty dramatically improve the performance for many of our users. This graph here shows the improvements at various percentiles, P25, P75, P99, for users in different countries. And this represents the user-measured home timeline request latency end-to-end. So it includes all the backend latency, the connection establishment latency, transit latency, et cetera, et cetera. And as you can see, in all of these countries, we've pretty dramatically improved some of the latency and even some of the earlier percentile latencies as well. We've seen this correspond to greater satisfaction and usage of Twitter in these regions as well, as failures have gone down and request success rate has gone up and latency has gone down. One additional benefit from using the public cloud edges, from using Google Load Balancer, has been additional capacity that we've gotten to use with no deployments on our end. This chart comes from a recent event in South America. There's a reality TV show called Big Brother Brazil that recently set the Guinness Book of World Records most online votes. It took this away from American Idol, I believe. And this purple line here shows the number of requests that happened at the peak of voting during the show, the number of requests to Twitter. And the red line on the bottom shows how much Twitter on-prem capacity we have in South America. And this peak was actually 3 times the amount of on-prem capacity that we have. So if we weren't able to burst into the public cloud and spill over into our other regions, Twitter likely would have been just hard down for the entire continent of South America. And by using the control tower to steer users to public cloud endpoints and spillover VIPs and other things that are performing well, we not only kept Twitter successfully up, but we were able to keep Twitter up with really fantastic performance for our end users at this time. Let me hand it off to Cynthia to talk a bit about the traffic director and hybrid networking.
So yeah, let's talk a little bit about Traffic Director. For those who don't know, Traffic Director is a managed control plane enabling global services with various types of backends and GCPs. So that could include GCE instances or GKE, and it programmatically configures Envoy proxies. So it actually leverages the Google Cloud Load Balancer, and this is a powerful way to serve applications globally via the Google network.
So it's Envoy.
Traffic Director additionally allows for hybrid connectivity, as it has the capability to route traffic to non-GCP backends. So it's an additional way Twitter can direct traffic to its data centers.
Got it.
All right, thanks for watching our talk.
Now it all
to
makes
the
sense.
end. We hope you learned a little bit about how Twitter scales with Google Edge networking. Wanted to also, if you wanted more information about Traffic Director, we have follow-up talks that will dive deeper into the Traffic Director capabilities amongst many of the other networking talks. I want to also have a special thanks to Todd and the Twitter team for walking us through how Twitter Edge deployment is using Google Cloud.
Great. Thanks so much, Cynthia. And a big thank you to Cynthia and to the Google team on this great partnership. We have more resources about the traffic control tower and how Twitter uses the Google Edge in the public cloud up on the Twitter engineering blog. So check that out and enjoy the other talks. And thank you very much. This was fun. Bye.
Interesting. Okay. Okay, there's crazy hair. So I thought that was sorcery there for a few minutes, and then they said Envoy right at the end, and I went, "Dope." Envoy's amazing. For those that don't know, Envoy is a sort of traffic management, traffic shaping, traffic routing, multi tool that was built by the team at Lyft, the ride-sharing company, originally, and it was open source, and it's just taken that sort of world by storm. And I'm not a networking guy, so I'm terrible at trying to explain what it actually does, but when you hook it in with some of the fundamentals of Istio, and you can do basically just dynamic traffic management, and then you take Twitter's, they've built their own backbone around the world, and then Google has their own backbone. And if you can simply use something like Envoy and policies in Envoy to, once you hit a certain threshold, route excess traffic beyond this threshold to this BGP route, it will send it over to Google's public cloud and their backbone. So basically, you don't skip a beat. You get a really big bill when it happens, but only when it happens. So think about Black Friday, think about the World Cup, think about the Olympics, all the things he was rattling off, right? The election cycles that are coming up here in the next few months. Twitter's going to be going crazy. But that's how it makes... Once he said Envoy, I went, oh! Duh! It makes all the sense in the world. And it's brilliant that we can... And the other thing I took away was they're not running any instances. There's no VMs. There's no storage. There's no nothing. They're just using the networking pops. I didn't know you could do that. So for anybody out there that's looking, that has a retail line of business, that has something that has very spiky demand, this would be an excellent solution to use Envoy to hook together your on-prem facility or your private facility with some of the additional burst to cloud. We've been saying cloud bursting for a decade now, but this is a legit example. What we just saw was a legit example of cloud bursting from a network standpoint. Really, really cool. As boring as some of that might have been, that was a really cool example that we can all kind of relate to, because we all use Twitter at this point. All right, what time is it? I think we got time for, probably one more quick one here. Schools too, onboarding students. That's another good one. I still don't think it'll be that big. Like, you're not going to get millions of people tweeting at the same time, like you would in the situation like, the BLM riots and things that we had recently, and the protests. And then you've got the stuff that went on in Venezuela, and then you've got the Arab Spring stuff that happened, over the last decade in Egypt and throughout the Middle East, and then big sporting events and things where people rush to Twitter to do things, right? That's what I think about. Millions and millions of people, either to stay up to date or to actively sort of announce and share what's going on in their neighborhoods, in their cities, things like that. That's where I think that's just wow. Totally useful. And the biggest use case is like retail. I think of traffic and IoT in Los Angeles and the Bay Area. I know for a fact they got sensors all over the freeways in Los Angeles. Those little rubber strips are all over every freeway to measure speed, count cars, count trucks, count accidents, count miles per hour. And all of that data is shared with Waze and Google and all of that stuff, right? So when you have hundreds of thousands, if not millions of people in Southern California that sit on freeways multiple times a day, every day of the week, I can see where that spikiness would constantly be needed. All right, one more. We just did a customer one. Let me look at the rest of my playlist and see if there's one more we can go through here. The Fitbit ones I'm curious about. Fitbit moved all of its production operations from managed hosting, i.e. a GoDaddy, to Google Cloud Platform without any downtime. 200 plus data stores. We decided to run our services in both hosting environments and move user by user. Okay, now I kind of do want to watch that one. Block storage is interesting. Maybe we'll save that one for another time. But, I mean, it's persistent disks, PDs and BDs. Was very interested to see the Windows workloads, managing Windows workloads But I definitely wanted to watch the Twitter one. Yeah, let's watch the Fitbit one, and then we'll probably call it a day. I'm still processing. Why is every company not doing something like that with a cloud provider? Why are they not bursting like that? It's a route statement and an ingress. It's an ingress variable in your YAML for your application. Why would you not do that? I don't know. It's one of those kinds of things where you just forehead slap and you go, duh, why didn't we do that? Interesting. All right, let's see what an actual user-by-user migration from shared hosting to full-on, I don't want to call it cloud native, but to cloud, what it actually looks like. I just really want to see this guy's hair.
Hello, and welcome to my talk, Do It Live, Fitbit's Zero Downtime Migration to GCP. I'm Sean Michael Lewis. I'm Principal Software Engineer at Fitbit, and I was in charge of moving our monolithic application from our legacy managed hosting to Google Cloud Platform. Today's talk, I'm going to talk about what was unique, or what we felt was unique about Fitbit's migration challenge. We're going to talk about how we thought about users in making decisions to move for our migration. Then we'll talk about the technology and processes that we added and affected to make this happen. We'll talk a little bit about how it went, which was quite well. And then we'll have some takeaways that we think could be useful for you should you be moving from another cloud provider or your own managed hosting into Google Cloud Platform. So, like many companies, Fitbit started with a monolithic application. We had a single binary that did all the things. It is quite large. It handles all of our traffic, or it did for a long time. And then we started to break it up into what we call microservices. It's pretty standard when a company matures. But while moving microservices might be quite easy, each service can do its own thing, move its own data store, figure things out, and move into the cloud. The monolith is much more challenging. It's a more challenging. It's bigger, meatier. It takes up about 70% of our traffic. So moving it was quite hard. So our migration wasn't going to happen until the monolith moved. So let's talk about our monolith. Like I said, it's a single Java binary, about 1,000 instances, backed by around 200 MySQL instances. Those MySQL instances are mostly sharded by user data. So if a request comes in, I can get all of my data from one shard. We have a sharding library that manages the shards. So it figures out where users go when new users sign up. It allows you to expand and contract the number of MySQL instances we have. And it also handles caching, for which we had around 400 nodes of memcache. We also have Kafka, where we do asynchronous processing, and those messages are largely processed by other instances within the monolith. So we'll talk about, we'll talk about our users now. Now that we know what the application looks like, we thought about what it would look like for us to move and who we should be thinking about as we're moving. The most important stakeholder in the move is your users. Sometimes doing the best thing for your users is not the most easy thing technically, but that should be the thing you do first, or the person you think about first. So how do we get to GCP with our users in mind? We thought about two different ways of doing this. One was to do it progressively.
All right, Gina, take it easy.
So move user by user, or batch of user by batch of user, or we could do it all at once. There are different pros and cons to each. For the progressive, we thought that anything bad that happened in the new environment as we were moving, any new challenge that we experienced in our new home, would be limited to only the users that have moved. So it's to be a smaller impact overall to our user base as we figured out things in the new environment. Secondly, like outside of normal availability problems, like just how our applications handle load in the new environment would be able to be observed in a more gradual fashion. We could see how the environment dealt with new load in a more measured way. We knew that network calls, we wouldn't be able to make every network call be in the new data center in GCP. So we would have to go back to the old data center sometimes, and that would incur a lot of latency. That's not a great user experience, but it's one of the downsides of this approach. And then lastly, we'd have to operate two full application stacks simultaneously, be able to operate them at the same time and manage them at the same time in two data centers and two different hosting idioms for us. On the contrary, the all-at-once solution, any challenges you have in the new environment, when you cut over the new environment, it affects everyone. So if you have a big outage, everyone's down. It's basically a total system shock. There's a lot of risk in that. You can do a lot of testing beforehand, but you don't know what's really going to happen until you flip the switch. The positive is that once you're in the new data center, all of your network calls are local, so your latency situation is as good as it's going to be. And while you don't have to maintain and operate two data centers at the same time, you need the old one on standby in case something goes wrong in the move. So you're not really getting rid of the old one when you cut over, at least until you're fully in. So which one did we choose? We felt that overall, thinking of the users in mind, that the progressive migration was going to be much better for them. On average, most users wouldn't experience any downtime or any noticeable downtime. That took some work, but we thought that if we could, slowly roll into GCP, we would give our users the best experience and maybe even one they don't notice. So as we were thinking about how we're going to do this progressive migration, we had to think about, what are the things we want out of it? How are we going to do it? And what are going to be our guiding principles? So the first one was to make our best effort to route users to the environment where their data is resident. As I said, we shard our data out by user. So if I move my data from our old hosting to GCP, I should start routing my requests to GCP. That was the goal of this migration, is to move the user with the data. We wanted to make sure that, let's say we didn't route correctly and my data is in GCP, but I got routed to the old data center. Well, that should still work. We still want that to be an experience. We don't want to be throwing errors when we have a misroute. So we want an experience no matter what. We want to be able to move users to GCP, but if things aren't going well, we need to be able to move them back. And we also need to be able to move at variable speed. If things are going great, we should be able to move users more quickly. If they're not going so well, or we're not sure, we should trickle them in and get our sea legs, as it were. Lastly, as we're making these decisions about fast, slow, forward, backwards, we don't want to be making a lot of gut check decisions. We want to be able to look at a chart and say, we're meeting our SLOs. We're going to have to move forward now. And so we actually need to develop more SLOs and have a better handle on them before we could do this appropriately. Let's talk about the timeline for this migration. So as I said, we wanted to move users slow and quickly at different varying times. But before that, we needed to actually set everything up in GCP and make sure it was working. And you can always run tests, but until you're really routing production users there, it's not real. So the first users that we routed were employees. We routed them through GCP. All their data was still in our old data center. They had slow experiences, but at the beginning, a lot of things were broken. But we fixed bugs until we had a complete experience. And all the meaningful experiences that happen in Fitbit were serviceable by going through GCP, and even if data was in another data center. Once we felt confident in that, we decided it was time to start moving paying customers. So we started moving users slowly in a slow trickle. When we got to watch as our systems took on that new traffic and make sure that we were able to operate and monitor and really, make sure that things were working in GCP. Then once we got a lot of confidence, we started moving users in big batches. We moved them quickly, and as you'll see, quicker than we even anticipated. So how did we change our architecture and technology to make this kind of move possible? As you'll see on the left, I had the same diagram for our monolithic architecture for our legacy data center. We replicated that in Google Cloud Platform, so the whole thing up. We had fewer application instances at the start and fewer MySQL instances, but and those MySQL instances were empty when we started as well, because they had no data in them. There was no data in GCP yet. And then we had connections from all the application instances to all the MySQLs in both the old data center and in GCP. So there's fully connected between those two data centers, between application instances. Those are the blue lines you'll see. The application instances go to, those are the lines that we had to add. We had to add connections back to the old data center from GCP and to GCP from the old data center. Then we added edge routing as well. This was the logic that would allow us to route users based on where they lived. So we had to be able to push that logic somewhere. It turns out we use Cloudflare, which is a CDN and DNS provider. They had a product called Cloudflare Workers that we were able to push logic up into and make these decisions. And I'll talk more about that later. But that made it so that we didn't have to go into one data center to decide that we really want to service it out of the other one and kick it back and redirect. It made everything much cleaner and easier to observe as well. And then lastly, we have connectivity between our Memcache instances. You'll notice that in this diagram, the applications only talk to their data center local Memcached. But if one application, if one data center makes a change to its local Memcache, we want that change to be replicated to the other one. And so we introduced a proxy that would allow us to echo invalidations to the other data center. I'll talk about that as well. First, we'll talk about moving users. I said we had initially empty databases in GCP and all of our full databases in our legacy data center. In our sharding scheme, we have this notion of buckets. Buckets have users in them. Mostly, there's only really two ways to do sharding. There's buckets and there's ID ranges. We use buckets. It's kind of like a hashing scheme, but it allows us to move an individual bucket one at a time. So we can move one bucket to any other database server. So when we were moving into GCP, we could move one bucket from a database server that lived in our old data center and then move it to GCP. Now the users have been moved. This is the slow method of movement. It takes about 20 minutes because there's a lot of locking involved. Users can still read their data, but they can't write for that 20 minutes. It's slow and gradual. We can add parallelism to get a little bit more speed, so we can do many buckets at a time. But we can't really move tons of users at once. To move fast, we move the whole shard. And this is a typical replication strategy, which is that our leader database would be in our old data center. We'd have a replica of it in
it's MySQL replication.
GCP. At some point, we would flip
natively
who the leader was and make the leader the one in GCP. Now, all the users on that shard, all those buckets, have shifted all at once. And that is a very fast thing. It takes about 5 minutes. It can go back and forward. Both of them are bidirectional, which is important for our use case. I'll talk a little bit about routing. As I said, Cloudflare Workers is the technology we use to provide some logic as to where user traffic should be routed. So we have this idea of buckets, as I told you about. There's a finite number of buckets. In fact, the number was finite enough that we could make a big map of it and push that map in a JavaScript binary up to this Cloudflare worker. We could also put a whitelist in there, which allowed us, is how we were able to route employees before paying customers. So regardless of where your data is resident, we could say, oh, this user should always go to GCP no matter what, no matter where their data is. Otherwise, see where their bucket lives. So this is the flow diagram. We have time deployments of the logic, the code that executes the logic, but also the data that feeds that logic. Gets time to deploy into Cloudflare. Then the logic is simply, is the user in the whitelist? If so, send them to GCP. If not, check where their bucket lives. Is the bucket in GCP? If yes, send them to GCP. If not, or we have some kind of error, or there's no user information, send them to the legacy data center. Eventually, once we had more than 50% movement into GCP, we made the default GCP. The last technical aspect was keeping the caches coherent. As I said, applications only talk to their local caches, and if the other data center changes the cache on their side, you want it to be reflected in both places. So we introduced a new piece of technology, McRouter, an open source Memcache proxy that has the ability to echo echo deletes and other operations to other data centers or other clusters of memcache nodes. Our second cluster just happened to be the other data center. This was pretty challenging for us, although it's pretty straightforward and it's a good tool. And we don't think a lot about it now. It was a stark difference from implementing the routing from before. The routing, being a managed service, ended up being really easy for us to do. It gave us very few headaches. We had very few incidents around it. Whereas introducing a new piece of technology just before you make a big move was much more challenging. It ended up working out for us, but it started to show us the differences between what might be possible when we have more managed services at our disposal. So how did this all go? It actually went quite well, better than I think any of us expected. The routing of employees before everyone else uncovered many critical bugs. So it uncovered around 60 bugs. We closed 58 of them before we moved to a paying customer. And I think those other 2 got closed as won't fix. They didn't end up being that critical. Really everything that was really blocking an experience in GCP was closed before we were able to do it. And we did that like live. Did it in production. I mean, we tested it in production without affecting our paying customers, which was super awesome. And then we also finished early. We had a pretty hard deadline to be out at a certain time. And we started this process. If you look at the left of this graph, you'll see that there's a very low trickle of information, of throughput going to GCP, which is the green line. And you'll see that it slowly steps up over time. And then around the end of August, or 8:30 on this chart, you'll see it takes a big step up, and then it takes some other bigger steps up and stays high. Based on our SLOs, we were able to see that we were doing well. Everything was kind of under control, and that we could really push this migration faster and get done sooner than we expected, which was super exciting for everyone. So what are the takeaways from this process? Progressive migrations based on user data locality can provide the best user experience for your users most of the time. If you have a sharded monolith like we do, you probably have some sort of user sharding or something like that. And so if you can do it little by little, that's going to be the best bang for your buck. Your movement should have options, both speed and direction. It gives you flexibility for when things go wrong or things go really well. Decide what is really good or really well based on your SLOs. And then also, we found that this was the first opportunity for us, having been in our own colo, to use managed services and really see the benefit of them. Now that we're in Google Cloud Platform, we think there's a lot more opportunities for us to do that. So if there are opportunities to use them in your migration, I would say you should. That's all. Thank you very much for your time, and I hope your migration goes well as well.
Interesting. So I think that's something that we as that was a good one. We as administrators, struggle with that pretty regularly when we're talking to C staff, when we're talking to app owners, lines of business owners, when we're talking to peers or junior admins or database DBAs, all of that. We have to explain to them what we're doing and why we're going to do it this way. And that was a great example. The beauty of cloud and what we just watched, and the thing that the promise of it is that it's seamless, and that technology has gotten to a point where it's not without errors, it's not without, but what I would love what he was so transparent about is that it exposed how short-sighted and how we were and how broken our stuff was, and how many bugs we had to fix just to move users from one place to another. I kind of love that. I couldn't stop looking at crazy hair, but I was really intently listening to what that experience was like, because we haven't heard too many experiences like that. I hear of a lot that I can't talk about publicly because NetApp, but there's a lot of these that are going on out there that you don't really hear about. I loved hearing that story. I've lived through several of those myself, moving between either shared hosting providers or between colo facilities or upgrading from a couple of racks into your own dedicated cage. I've been a contract worker that did the work for the company, and I've been the lead engineer at a company that went through that. So I've done my share over the last 20 years of those kinds of migrations, and I heard pain points. Even now, even in 2020, moving things from on-prem to the cloud, I heard similar pain points. The databases are built a certain way, they are maintained a certain way, and the DBAs have a way of doing their thing, so you have to accommodate them as just as much, if not more, than you're accommodating your end user experience during the migration. There are all kinds of things, left, right, and center, that you are the middleman for, in a way. You're building this sort of web of satisfaction. Are you satisfying the IT leadership? Are you satisfying your end users? Are you satisfying your junior admins and DBAs and app developers? All of these things, are you checking all those boxes of all of their wants and needs and desires? I think that's a big part of doing jobs like this. Big migrations. Also, the thing that was really impressive about that was they did that in less than a month from start to finish. I saw 8/22, August 22nd was the start, and it looked like they were done by September 13th. Wow. Bravo. Bravo indeed. I was looking through the rest of these. There's definitely some that I want to look into, but those were the big ones that I wanted to look at, and I didn't want to run this for much longer than 2 hours, and we're over that at this point. So I want to wrap up here by saying, first of all, thanks everybody for stopping by and for joining the watch party. We got a lot of these coming up. We're doing a lot of planning right now for VMworld coming up at the end of September over in our Discord community. So if you don't happen to be in our Discord, I'm going to throw a link to it in the chat, and you guys will see that there. But make sure you come over and get into our Discord. We do a lot of these virtual events. Some of them we host directly in the Discord channel in live screen shares and voice channels where people can participate. We got a lot of stuff coming that's going to be a massive 2-day spectacle for VMworld coming up. It's going to be our first really big one that we're doing. If you haven't seen any of the other watch parties that we've done here on the channel, check those out. Got a whole playlist for them going all the way back to reInvent and KubeCon from last fall. Microsoft Build was a really good one, well-attended type of thing, but I'm looking to try and find what is the best way in a post-COVID world of virtual events. How do we do these? And I want to sort of chart the course. If I got to come out here and stream to 8 people that want to watch all of this together, I just want to breed that sense of togetherness again, that we're bringing everybody back together. So whether it's 8 people or 10,000 people, it's a matter of how do we bring everybody together to attend an event? And I'll do air quotes and say attend an event in the best way we can. And I think that's going to be a myriad of things. It's going to be some YouTube, some Twitch, some Discord. We have to treat this differently. We can't just repurpose what we've done for the last 40 years of trade shows and somehow plop it into a Zoom meeting and some pre-recorded YouTube videos and call it an event. It's really not. We got to think about. We got to start. We got to do what Microsoft did with Build. We got to start from scratch. We got to strip it all away and go back to one. And I think that there's not enough of that happening right now. There's this gut shot. Oh, we got to get something done, and throw it out there. And we call it an event. But it's not an event. It's a YouTube playlist. You know? So I think that the beauty of this is that we've got the opportunity. Without, glass half full perspective, without the pandemic, we wouldn't have had the opportunity to really look at this. And really take a step back and look at how we want the trick is going to be getting the tried and true folks that are so hell-bent on having live events and that being the only way they know how to do things. we have to kind of get them on board. We have to get people to open their eyes a little bit and understand that things are different. And if we're going to be sitting at home giving presentations and you know, mini TED Talks, solo, without an audience, staring into a lens of a camera, how do we make that interactive? Why do we do trade shows in the first place? It's the interactivity. It's not the lead engineer from Fitbit getting up and talking about how they migrated stuff. Cool, very cool, but I could have watched that on a YouTube video, which we just did. It's not an event. It's not an interactive thing. It's not a venue. It's not a destination. There's no networking. There's no swag. There's no interaction. So how do we get there? That's what I'll give you all a homework assignment of. Challenge your events teams to do things differently, not just try to fake what they're used to doing on some online platform. Think, to quote Steve Jobs, think different. How do we do this differently? Think about it. Come chat about it over in Discord with us. We've got a whole channel dedicated to virtual events. And this is a nut I'm trying to crack. This is a problem I'm trying to solve. I'm working with folks inside of NetApp to look at how we can do this differently with live streaming. All kinds. We're gonna pilot this with VMworld at the end of September. We've got some ideas, and VMware's on board. We had a great meeting with VMware. Shout out to Eric, and we've got some big ideas, and we're gonna see if we can pull it off. But we need people. You still have to staff it. You still have to there's still stand manning to do. There's still, but it's just different. You're not standing at a kiosk. You're hosting a screen share in a Discord channel for other people to come and join and watch. And that could be videos or demos or live streams of content with SMEs and experts. So all of these are on the table. The technology's here. We can do it. We just have to want to try. Come find us in the Discord, guys. Thanks very much for everybody for hanging out. Appreciate it. My name's Nick Howell. I'll see you guys for the next one, which I believe will be Storage Field Day at the end of August. I think we got a good break here between the next one, but we're going to be doing week 7 of Google Cloud, which is the app modernization track. Yeah, it's right here on the screen. App modernization. And we'll be back to do a bunch more videos and watch parties for that. But thanks for tuning in for Google Cloud, guys. We'll see you next time. Peace.